All right, guys, we're going to deal with some square roots. So this might be a little bit of review of what we talked about, but that's a good thing to make sure that we have the whole thing. What we're also going to do is we're going to start to change out the index. Remember, the index is this little number inside that square root. So when we have a regular square root, let's say of 4, right, this number would be 2. It's assumed to be 2, so we don't write anything in there. Okay, so we know the square root of 4 turns out to be 2. But the cube root of 4, there's nothing we can do with it, right? That would be simplified because now I'm looking for sets of 3. And we know 4 is made up of 2 2s. But if I don't get a third one, there's nothing I can do with it. So that's kind of the skinny of what we're going to deal with today. We're also going to add in the fact that we can't take the square root of a negative, right? Because it would give me a non-real number. We'll get into that in this chapter as well. Okay, but for today, we'll just call it non-real. Okay, so this time we're after cube roots, and we're going to put you through the ringer a little bit. So the cube root 0.008, that is 8 over 1,000. So remember, if I'm dealing with a cube root, I can do these two separately. Okay, so 8 is made up of 2 times 4, and that's 2 times 2 times 2. So that's 2 and 1,000. The cube root of 1,000, well, notice there's 3 zeros because that's 3 tens, right? So that's 0.2, 2 tenths, we're finally 1/5, right? These are the two acceptable answers of what we would have. Now here's the deal. We're dealing with a cube root, so negative 1,000. That's okay. What we're going to do is we're going to say we have negative 1 3 times, so it becomes negative. And for the 1,000, we just realized that the cube root of 1,000 is 10. So we get negative 10 for our second problem. Now 1 over 27, we have this fraction. We're trying to do the cube root. So as I do this, I'm going to go ahead and separate them so we can see what's going on. The cube root of 1 is 1, right? 1's always going to be perfect for everything. And 27, what is that? That's 3 times 9. 3 times, look at that. I have a set of 3's. So it is 1/3. It was all positive, so it stays all positive to deal with that. Okay, so in the next set, what I'm going to do is I'm going to change out some of the indexes. So we have to pay a little bit of attention to what they're asking for. So we're asking for a cube root, so a negative is okay, which means my final answer should be negative. And 8 is made up of 2 and 4, and that's 2 and 2. So I do get a set of 2's, so this one becomes plain old negative 2. For 0.04, remember that is 4, right, tenths, hundredths, 4 hundredths. I do want to keep my square root on each of these guys. So I get 2 over 10, 1/5, or 0.2. These are my two acceptable answers that I reduce those. I have, in this one, my index is 4, which is even, and then I'm trying to take the even root of a negative. So in this one, there is no reals. Okay, there's no real answer to that one. We'll deal with what it is. In the next one, what we do is we have this square and this square root that are going to cancel each other out. So we'll get a negative 2. So this will be the only situation where we can deal with that. Okay, because we know those are inverse operations. All right, so here's the next set. So if you want to pause and try these out and then come back, I'm going to go through them just to see how we're doing. So cube root of 27, right? We said 9 and 3, 3 and 3. Did you pause it or are you just following along? Okay, so negative 3 becomes our final answer. And the next one, I see even and a negative. So I'm going to go straight to saying no reals. All right, in the next one, my square and square root cancel. So negative 7 it is. And in part D, I see that I have a negative under here. And if there's nothing in here, remember that's a 2. So that's an even, so this is no reals. All right, so we're going to add one extra thing in here. If we're going to deal with some variables or even with some numbers, I need to look out because it's possible that if I end up with x squared outside of a cube root, there could be some issues here. Okay, but it's more so if I end up with an odd outside of an even, that I need to clarify that this being an odd power, if it were negative 1, it would stay negative 1, but I certainly couldn't take out a set of negative 1s from a square root. So this we're going to look out for, and that's what they're saying here is if that happens, if you go from an even index to an odd power, we're going to give this guy some absolute value bars on it. Okay, so we might write things out of order so it doesn't look really, really weird. But we'll deal with that when it shows up here. So we're looking for evens that go to odds. So here's what we're looking out for. What's the square root of 16? Well, that's plain old 4, so that's not a big deal. And for x to the 8th, so that means 8 of them, so there's 4 pairs. So that one we're okay with. All right, this one, we're dealing with a cube root, and cube roots can be negative, so I don't have to worry about anything else. But if I had 8 to the 6th, so that's 6 of them, divided by 3 gives me 2, and 9 of them divided by 3 gives me 3, right? So that would be 3 sets. So we're okay there as well. So nothing happened just yet with that absolute value. So if there's 3 in the set, then this one must have that extra thing going on. So I'm looking for sets of 4, and I have 8. So that's x squared, right? Because 8 divided by 4 gives me 2. What about y? 12 divided by 4 gives me 3. All right, so here's where it's at, guys. I went from that even index, I got an odd power. So to clarify that this one must be positive, I'm going to put the absolute value bars right on top of the y to the third. Okay, x squared does not require them and should not have them because that will always work itself out. All right, so here's a quick little problem set to give that another whirl to see what we're doing. Square root of 81 is 9, and x to the 4th is x squared. Okay, so numerically, we're not overly excited about these unless we have negative signs. We deal with that by itself. So what I'm looking for is the fact that this was an index of 2, so it's even and went to even, so I'm in good shape. So what happens is I really start to like the odd indexes because then I don't have to worry about anything else. Okay, so 12 divided by 3 is going to give me 4, so a to the 4th, right? Why am I doing that? Because I'm looking for sets of 3, and if I had 12 of them, there would be 4 sets of 3. B, 15 divided by 3, that's going to be 5. Remember, this was an odd, so I don't have to worry about anything extra. Now I'm back to an even, so that means I'm thinking about absolute value bars. I get x to the 12th, so that's x to the 3rd, y to the 4th. All right, here we go. So I went from even to odd, so my x to the 3rd has to be surrounded by the absolute value bars in my final answer. All right, that's the whole thing today, guys. We're just looking out for, remember, it is from even to odd, even to odd.